Good morning, dear students. Hope you are good. And I'm thinking that you are listening classes regularly. Don't waste your time. Please listen to class. And I've been observing that most of the people are not watching. Watching in the sense in the prescribed timings. Every day, I'm observing the people who are listening these classes. Hope you know. Faculty can easily check whether they are listening or not by using in that Google Classroom only. We can understand who are following classes and who are not following the classes. What I am speaking is here. Please try to concentrate and try to listen the classes regularly. And I've been asking you if you have any doubts. Please contact me. And the material will be available in college bookstore soon. Hard copies. And as part of today's session, as we are in the treatment works, after the treatment, after the major treatment technologies, treatment methods like sedimentation, coagulation, filtration, we are focused on how to remove the fine and ultra-fine particles before we are supplying water to the public. Dear students, as part of today's session, today we'll discuss about very familiar technology, what you are regularly hearing and watching, and even our college also having the filtration system, that is nothing but reverse osmosis technique. What is exactly happening in this reverse osmosis technique, I will discuss. In this technology, nothing is there. You go to the slides. Reverse osmosis. This process mainly focused to remove contaminants from unfiltered water. In one meaning, of course, the filtration in the sense we crossed that filter beds, normal sense, removal of contaminants from the water. See here, the pressure is being applied. This is a basic. This is a nice illustration of what is osmosis and what is reverse osmosis. It has taken from internet, and the material of the image and associated topic is available net for your better understanding. We are going through this. See, have a look over there. Osmosis. Water is just moving to a concentrated side, low concentration to high concentration. Whereas here, high concentrated seawater here, moving towards the fresh water. Have a look here. When the pressure is applying, how much of pressure? 100 to 800 psi. pounds per square inch. See here, 100 to 800 psi applied to a semi-permeable membrane, then water moves from the more concentrated side to the less concentrated side to provide drinking water, right? This is more concentrated side. Applying pressure, how much? 100 to 800 psi units. By doing so, water moves through the semi-permeable membrane, this more concentrated zone 2 through semi-permeable membrane enters into the low concentrated zone. That's what the slide is speaking to us. The clean water produced, this is called as permeate, and the leftover water is called the waste or brine. Brine. Understand? Permeate and brine. See here. Normally, what happens in osmosis? This is also explained to you. Already you got the point. Water moves from this low concentrated to high concentrated zone through semi-permeable membrane. This is normal osmosis. But whereas in reverse osmosis, the water is moving because we are applying pressure. That is the reason water is moving from high concentrated zone to low concentrated zone. See here, in osmosis, molecules of solvent tend to pass through semi-permeable membrane from a less concentrated solution into a more concentrated one to obtain equilibrium on both the sides. Now, this is the simple mechanism how you should write when you got a question. No, reverse osmosis. Water is passing, or else water is flowing, or else water can be flow, or else made the water to flow from high concentrated to low concentrated zone by applying pressure up to 100 to 800 psi units, where the water flows through semi-permeable membrane from high concentrated to low concentrated zone, called as reverse osmosis. The water whichever passed from whatever the water content passed from the high concentrated to low concentrated zone, called as permeate, and the leftover water is called as brine or wastewater. See here, what happening exactly here? When water first enters, it goes through pre-filtration, where sediments and other substances which could clog or damage the RO membrane will be removed by a carbon filter and a sediment filter. I am speaking about the mechanism. I told you in one point what happening, exact procedure, but what happening in RO units. As water enters into that unit, all the sediments and other associated substances will be stopped there itself. They won't come to the filter. Followed by water flows. Then see here, then water flows through the RO membrane, where dissolved particles and other fine particles will be removed. At this stage, after crossing the semi-permeable membrane, the water will be stored in storage chamber, and it will continue till the chamber is filled. What are the advantages here? It is easy to maintain, and energy requirements are low. It reduces harmful dissolved contaminants, reduces sodium concentrate in the water, and reduces bad unwanted odor source. Understand? This is about reverse osmosis. Reverse. What is osmosis? Water is passing, water is moving from concentrated to high concentrated, that is osmosis. Whereas reverse osmosis, in the sense, water is moving from high concentrated to low concentrated. What you should remember, how much of pressure is applying. What you should remember, the clean water produced is called as permeate, and leftover part is called as brine or waste. Stages, when the sediments and all other associated particles will be entered there itself, at the entrance itself to the unit, and then water passes through the semi-permeable membrane. where all the particles will be removed. Through semi-membrane water will be stored. After passing through the RO membrane, the water will be stored in storage chamber and it will continue till the filling of or else till the storage chamber is full. What are the requirements? What are the advantages? Environmental friendly, low energy requirements, harmful dissolved, all harmful dissolved contaminants will be eliminated and reduces sodium concentration as well as it removes the bad and unwanted odors. This is about the reverse osmosis. Next is adsorption. What is adsorption here? Here adsorption is nothing there, nothing is there here. First of all, why it is using, where it is using. Adsorption is widely used in drinking water treatment to remove organic substances. And it mostly practices a tertiary water treatment, primary, secondary, tertiary. What is the difference? We'll discuss in the days to come. The principle of adsorption and the ability of certain solid materials to remove dissolved substance from water. Carbon adsorption is widely used in method of home water treatment because of its ability to improve water quality. See, what I want to speak about this topic is this is widely used in drinking water. Areas, or in drinking water treatment plants, or water treatment units. What happening exactly here in this adsorption? Simply, the process adsorption, the materials that are used in this adsorption called as adsorbents. The charcoal, activated carbon, silica gel, zeolite, all these are the example for adsorbents. One more time, adsorption. That is not absorption. This is adsorption. First point, this will be used in wastewater treatment, and also and mostly it is used to remove disagreeable taste, odor, including objectionable chlorine, organic matter, and all can be eliminated by this adsorption methods. The substances that are used in this process called as adsorbents. Example for adsorbents are activated carbon, silica gel, zeolite, etc. See, these materials are trying to make bond. What is the tendency of these materials? These are trying to make bond. Why? Because they have one vacant atom, vacant element, vacancy in their configuration, vacant atoms, or else vacant electrons, more particularly. They want to make bond with because they have vacancy in their configuration. They have vacancy, vacant electrons. They want to make the bond. They want to make the bond with other single, such type of. See what happening here. Listen, focus. See here, activated carbon, charcoal, silica, all these are adsorbents. They make bond, or else they make bond with vacant atoms or electrons of the waste materials of the water and comes out as filtrate. Understand what they are trying to do? Because they have vacancy in their molecular and atomic configurations. They have that. Because of the vacancy, they try to make bond with the other similar charged particles of waste materials and comes out as a filtrate. Understand? What is adsorbent? The substances which are used in adsorption procedure called as adsorbents. What are the example? Silica gel, zeolite, and even activated carbon, so on. As they have the vacancy in their molecular configurations, they try to make bond always with other similar vacant waste materials or else other similar vacant particles in the wastewater or else contaminants in the wastewater, and after making bond they come out as a filtrate that is called as adsorption. See here, it removes pesticides, other synthetic organic chemicals, chlorinated hydrocarbons, cadmium, and all type of waste materials can be removed as they have the vacancy, the molecular configuration. They try to make the bond with the other similar vacant contaminant particles. Once they form bonds, they come out as filtrate. They comes out as filtrate. See, adsorption takes place when a molecule in a liquid bind themselves to the surface of a solid. Why they are trying to bind? Because they have vacancy. Adsorption takes place when molecule in a liquid bind themselves to the surface of a solid substances. Activated carbon is by far most commonly used adsorbent and particularly suited to the removal of polar compounds. I told you 3 examples: activated carbon, silica gel, charcoal, even zeolite can be considered as adsorbents. See, activated carbon example I have taken here. Activated carbon can be used as powder form, granule form, or in impregnated form. Impregnated is a soak, which is saturated. Soak mode. See, open filters are primarily used in drinking water applications. See how they are doing. See here, the carbon, when activated carbon is using, water is making on arrangements will be done where the water will pass through that particular adsorbent. As the water flows through those adsorbents, they forms bonds and removes the contaminant substances. Once it reaches, see here, in this point in time, the carbon becomes saturated and reduces the effectiveness of the filter. In such cases, the carbon can be thermally regenerated. For that, there are different techniques. See, what we should focus here is simple. What is adsorption? The removal of waste materials from the water can be absorbed by the addition of the substances like charcoal, silica gel, zeolite, activated carbon, where the vacancy of electrons are observed. Because of the vacancy, they tend to make bonds with the similar type of contaminants in the water and comes out as a filtrate. This process is called as adsorption in one word and simple terms. See, whenever activated carbon is using as an adsorbent, the water it will be done. The arrangements will be done where the water flows through the adsorbent. By doing so, the adsorbents. What is the work of adsorbent? It try to make bonds with the waste materials of the water. Understand? Once it makes bonds, it comes out as filtrate. Whenever the efficiency of carbon is saturated, we can observe the other end by observing the water that is filtered. At that time, we can regenerate this active carbon or as activated carbon by using regenerating techniques. Understand? This is about adsorption. Okay. Today we discussed about reverse osmosis and adsorption. Today we will discuss about reverse osmosis and adsorption. Where reverse osmosis water is allowing to move from high concentrated to low concentrated zone by applying pressure of 100 to 800 pounds per square inches, PSI units. The water that is moved is called as permeate, and water that is left is called as brine. Already we discussed. This is a diagram. You must write, you must draw the diagram. Please learn it and try to draw the concept when you got the question in your examinations. Advantages, adsorption. Okay. If you have any doubts, please contact me either message, phone, or mail. Thank you.